Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We've made it all the way to June 3rd this time around. Welcome to meteorological summer. This is as moonless a week as we get. It's actually hard to see the moon this week. It starts the week in the morning sky waning, but just less than 10% full. You got to work to see it. By the time we get to the evening of the 9th of June, you will appear about 15% full, so a beautiful crescent moon in the evening by the end of the week. But it takes us all week to get there, so we don't have a lot of moon interference, no excuse for not going out and observing some things. On that evening, it'll sit about 5 or 6 degrees west of the Beehive star cluster, M44 in Cancer. This is one of the biggest, brightest star clusters we have. It's visible to the naked eye without any optical aid. A pair of binoculars is going to be your friend here. You're going to be able to see a thin crescent moon, and east of that thin crescent moon, you're going to be able to see the Beehive star cluster, glittering stars in there. So check this out. The timing needs to be just a little bit right. When you got a 15% full moon, it's up well after sunset, you can see it, but it's still a little bit of glow in the sky for most of the time that you're observing it. And then by the time it gets good and dark, this whole thing is settling pretty close to the horizon. And that's all great for the moon. But when you're looking at an open star cluster, it's better than a globular star cluster, which is better than a nebula, which is better than most galaxies you look at. So you get the idea. But the timing wants to be just about right. You want it to be dark, but not have settled too close to the western horizon. So give that a try. We've also been looking at the planets in the morning sky. A lot of stuff out there right now about the great alignment of the planets. I'm here to tell you, they're stretched pretty far across the sky. This week, anyway, you still got Venus in the evening sky. You've still got Jupiter too close to the sun to observe. Anyway, you get where we're coming from with that. We've been watching Saturn and Mars move against the background stars, and we're going to continue to do it this week with Mars. Mars starts the week about 1 3/4 degrees to the west of the star Omicron Piscium, the Omicron star in Pisces. And that's about a 4.3 magnitude star. We've talked about this a lot, of course. The magnitude system counts backward, and your limit's somewhere around 5 often for most people in most skies. So this is a visible star, but not an easily visible star. And again, binoculars will help you out a lot. 1 3/4 degrees, a couple of finger widths at arm's length, and the motion is dramatic. That's the morning of the 4th we're talking about. This is before sunrise. So we're looking at it a couple hours before sunrise. So we're talking about the morning of the 4th. 2 days later, the morning of the 6th, Mars is almost right on top of Omicron Piscium, right over it to the north, about a half a degree. So it's closed this thing down to a half a degree, depending on where you are. If you're west of where I am, in the central part of the United States, you might be able to see it even less than that, because it's sliding that way. By the time we get daylight, that's about the tightest I'm going to be able to see it. By the next night, one morning later, still a couple hours before sunrise, it'll have opened back up to about 3/4 of a degree, and you'll notice that Mars has moved east of Omicron Piscium. So the motion is quite noticeable. By the end of the week that we're looking at here, the morning of the 10th, it's opened up to 2 3/4 degrees, which is, a full degree bigger than where it started the week and on the other side of Omicron Piscium. So this is a great, great week. If you got clear skies every morning and you don't feel like sleeping, go ahead and get up early in the morning and go out and check this out and see. Just watch Mars trucking along. I flash back to the 70s when I was a kid, and everybody was wanting to say, keep on trucking. And so this is what Mars is doing, trucking along here, moving from one side to the other. So we'll take advantage of the dark sky this week to look at the region of the Big Dipper, of Ursa Major, and some objects in there. And you can see the erasing that I did here. Ursa Major and Ursa Minor, the Big Dipper and Little Dipper, so familiar. I've been observing them for the better part of 5 decades. And I've been seeing them in the night sky, and I go out and I look for them. I find them. And I live, where they're far enough north where they're high in the sky anytime I look to see. And And I think that makes it problematic when I try to do a freehand drawing. It never looks right to me, and I finally just give up. Right? It's like anyway. The Big Dipper here is we've got the 2 pointer stars in the Dipper, Merak and Dubhe. And that's the bowl, the two stars in the end of the bowl of the Big Dipper. They point up here. You got to curl. There's the handle of the Big Dipper back that direction. You got to curl just a little bit right to get to Polaris. So Polaris is here. I had that written on the board at one time. That's how much erasing I did. I destroyed the name of our North Star. So Polaris is there. We're talking about second magnitude stars across here. To me, these stars look brighter than Polaris, but then you've got fainter stars in the handle of the Little Dipper, and so Polaris is the end star in the handle of the Little Dipper, right almost directly on our rotational axis, so it doesn't appear to move much at all in the night sky. That's its value. Now, as you move out this direction, if you go up about the same distance, and I've tried to draw this over here, we can move to that drawing in just a second. If you go about the same distance as you go from Merak to Dubhe, and then about half that distance again, right in there, the same distance and about half that distance again, you've got M81 and M82. These are beautiful galaxies. These are as good a galaxies as you're going to find. They appear. You've got a nice low power low magnification eyepiece. This is what you want to be observing nebulae and galaxies and stuff, is a low magnification, wide field of view. There you're going to see both of these. You can get them both in the same field of view. It's spectacular. It's really, really worth trying to find these two galaxies and spending a little bit of time. And this is a good week to do it. Dark all week. If you live far enough north to be able to see this region of the sky, it's great. Now, if you continue on about that same distance, so you went up this distance, about half that distance over to M81 M82, and you go about that distance again, there's a group of a few little stars there, and one of these stars is Sigma 1, Ursa Majoris, and it's a great binary star. What is it? 5 arc seconds separates the two stars right now. Easy to split. Beautiful binary star. So you're in the region. See if you can do this. 5.2 magnitude. Yeah, I wrote it over there. 5.15, I think. So 5.2 magnitude. Sigma 1 is that star. There's a group of about 3 stars. I think, if I remember, when you draw a great bear on this, the way people usually draw it, I think this is the ear of the bear that you see right there is this grouping of stars. That's not something I've paid a whole lot of attention to over the years, so I think I have that right. Anyway, Sigma 1, 5.2 magnitude, beautiful binary star, 5 or 6 arc seconds separates them. Pretty easy to separate and looks good in a small telescope. Now, if you're down here and you move about, I'm going to say 40% of the way across the bottom of the bowl of the Big Dipper, and then drop just below there, you get M97. And I've drawn that over here too. There's your pointer stars, and there was your trip up to M81 M82 and on over to Sigma. I drew this for myself over here. So right now, the Big Dipper's high in the sky. When the Big Dipper's high in the sky, it looks like it's pouring its contents into the bowl of the Little Dipper. And for me, when I'm picturing how I want to go find these things, for whatever reason, I always picture the Big Dipper sitting upright, so its bowl is staying full. And so that's what I was doing over here, was drawing this for my own benefit to be able to sketch that and figure out where I'm going right here. And so you come back over this direction on the bottom of the bowl. The bottom of the bowl's up in the sky right now, and you're moving back that direction. You come across M97. M97 is a planetary nebula. Not a super bright planetary nebula, but definitely visible. Any small telescope you have ought to be able to pull this out. A planetary nebula is a low-mass star like the sun that has puffed off its outer layers. It's gotten rid of its envelope. All that's left is the core. There's a white dwarf star down in the middle of that, and the rest of the stuff, when I say puffed off, it's pretty violent. It's not like a supernova explosion that disrupts the star, but there's the star, as a star ages, and it goes through the red giant phase, and then the horizontal branch phase, and then it becomes an asymptotic giant branch star. It gets bigger and bigger and bigger, and as it gets bigger and bigger and bigger, because the core gets hotter and hotter and hotter, and it pushes the outer layers out. And that expansion of the outer layers causes the outer layers to get cooler and cooler and cooler. And that's what makes it a red giant, because the surface is cool. You look at, oh, that star's not hot at all. But down in the core it is. And so it has pushed that outer layer out. It's gotten very bright and very red and very large. But as it pushes that outer layer out, that surface of the star is getting farther and farther and farther away from the gravitational center of the star. And it's being held very tenuously. It's hard for the star to hold that surface on, and it's got these sort of nuclear explosions going on down inside it too, and shells around there. You get a hydrogen to helium burning shell turn on, and then it'll turn off, and a helium to carbon burning shell will turn on, and those things will cycle back and forth and move further and further out closer to the surface. And so you've got these big sort of events occurring closer to the surface of the star, and the star getting pushed out until finally the star is just too far. The surface of the star is just too far out there. Off it goes, and you've got yourself a planetary nebula with a white dwarf star. It's not burning nuclear fuel anymore. It's just the core of what was carbon, nitrogen, oxygen, of what was burned in the star, and this puffs up, this expands out. It's pushed out into space, not gravitationally bound to this anymore. And that's what happens. It's relatively small, right, compared to other things in the sky. And by the time it gets really big, it's hard to see because it's thinned out so much. But the Owl Nebula, M97, that's what that is. The Owl Nebula is a really good example of that. So it's a really nice example in Ursa Major. So while you're up here exploring the Big Dipper and the Little Dipper, give that a look. Think about what's going on. Think about the history of that star. Be sure to check out M81 and M82. They're fabulous galaxies. Sigma 1, good binary star. When you're ticking off all the binary stars you want to go see, don't forget to check out Mars, moving next to Omicron Piscium. And you've got the Beehive Cluster, an open star cluster in the disk of our galaxy. It's in Cancer. You've got the moon sitting right next to that, right at the very end of the week. As always, thanks for watching, everybody, and hope you have a great week.